is our second Kirchhoff's nodal analysis. So again, let's look for the positive sides of the supplies and deal with our currents first. So the positive side of that supply, make that supply 1, make this one supply 2, positive side of the supply. Positive side of the supply of V1 generates the current I1. Positive side of the supply V2 generates the current I2. What you should notice when these come round and hit this junction is I1 would then be coming down the way and I2 would be coming up the way. So you have a choice at this point. You can either describe this current coming down the middle as being in this direction and being I1 minus I2, like that, because I2 would be coming up the way, so in the negative direction. Or you could describe it as going the I2 direction and make it I2 minus I1. Either is acceptable. At this stage, it's just a guess. And you need a guess to kind of get started. So for no reason other than the supply V1 is bigger than the supply V2, I'm going to guess that my overall direction down here is in the I1 direction and that it's I1 minus I2. That's what I'm guessing. So that's me dealt with the Kirchhoff's current law part of it. So now I'm going to label my circuit. And look at the voltage law part of this. So I'm going to look at my first loop here, A, B, E, F. And in this loop, I've got a 10 volt supply. Then V equals I times R for this one here. I1 times 6. And then going in the same direction in this loop here. V equals I times R, so it's I1 minus I2 times 10. And then I can simplify this. And you should notice that it's a negative 10 I2 when you multiply out your minus I2 times 10. And you collect like terms, the same as you always do. Oh, that should be an I1, sorry. It's I1 times 10. So that'll get you 16 I1 minus 10 I2. And that would be your equation 1. Then the next loop I'm going to look at will be this loop here to the right. B, C, D, E. My supply in this loop is 8. And again, I times R for this one. And then I times R for this one. The difficulty you've got here, when you follow around I2, looking at the direction of that arrow, it's going against that. So it's not I1 minus I2, it's negative I1 minus I2. Because if you follow around that I2 arrow, it goes against that I1 minus I2, giving you that negative sign in there, multiplied by that 10. Then you've got negative times I1 times 10. Then you've got negative times negative I2, giving you a positive, times 10. Then you collect your I1s together and your I2s together. And have a look at these equations and think to yourself, is there anything that's simple, anything that's straightforward? Can you multiply one to get a number in the other? I don't see that there. But I do see 16 and 10 as being quite similar, as in 16 and 10 both fit into 80. So that's what I'm going to go for. 80 is my kind of target number. So I'm going to do equation 1 times 5. So 5 tens is 50. 5 16s is 80. And 5 tens again is 50. And that's my equation 3. Then I'm going to do my second equation times 8. 8 times 8 is 64. 8 times negative 10 is minus 80. And 8 times 18 is 144. That's equation 4. Now, the reason I was looking at 80 is so that I get positive 80 in one equation, negative 80 in the other. So now, when I go on and I add these two equations together, and I get 50, and I add on 64, let's see, 50, add on 64, I get 114. 80 plus negative 80 gets me 0. Then negative 50 plus 144 gets me 94. So my I2 is going to be that 114 divided by 94. And I'll round that to 0.213. And that's my value for I2. I'm going to now substitute for that in either equation 1 or 2. It doesn't make any difference. You could make it 3 or 4 as well. I'll substitute it in 1. So 10 equals 16I1 minus 10 times this value of I2, 1.213. So it's 16I1 minus 12.13. Then when I change sign for this one, it goes from being negative to being positive. And it gives me an I1 value of 22.13 divided by 60. 1.383 to 4 significant figures. Okay, so just to make sure that this is all correct and everything's going fine so far, I'm going to put my values for I1 and I2 into equation 2 because I didn't use that for my substitution, I used equation 1. So I'm going to do negative 10 times I1 plus 18 times I2 and I get 8. So I get 8.004, which pretty much checks with that. So I've used this equation as a check. And that's proved my I1 and my I2 values are okay. Now the other thing I decided was that I1 take away I2 gave me that current there. So for this to be correct, I1 must be bigger than I2. I1 is bigger than I2. So because I1 is bigger than I2, the direction I guessed is correct. So my current through my load resistor, my IL, is I1 minus I2, 1.383 minus 1.213. So 1.383 minus 1.213. Gives me 0.17. And the voltage across the load resistor, IL times RL. So that's that 0.17 times 10 is 1.7 volts. And that's that second example complete.